Hello everyone. Today we'll start with the fourth module of design of bridges. In third module we have girder beams. Okay, after this fourth module we'll go for the third module. We'll start with the third module, that is box culvert. So in the first class, in the introduction class, I have shown you the images of various bridge structures. So in that I have shown you the box culvert also, which is used whenever a small water body passes by the path. Okay, so in rural areas, on state highways or national highways, you must have seen the box culvert where it is constructed to cross the water body across the path. Okay, so the maximum span for the box culvert is 3 meters to 4 meters. Okay, box culvert consisting of two horizontal and two vertical slabs. It will be in the shape of box. Box culverts consisting of two horizontal and two vertical slabs built monolithically are ideally suited for a road or a railway bridge crossing with high embankments crossing a with limited flow. Okay, reinforced concrete rigid frame box culverts with a square or rectangular openings are used up to a span of 4 meters. If the 4 meter span exceeds, you should go for the other structures, right? So the height of the vent generally does not exceed 3 meters. So 4 meter by 3 meter will be the maximum span of the box culvert. So it is used to pass the water body across a path. Okay. So now we will see the design loads which are to be considered for the design of box culverts. So one general section we will see here. So it will be something like this. See here, box culvert. Okay, rested on the ground. Once you rest on the ground, there will be upward pressure due to the resting it on the soil. Okay, there will be upward pressure at the bottom. Now we will see what are the design loads to be considered for the design of box culverts. The structural design of reinforced concrete box culvert comprises of the detailed analysis of the rigid frame for moments, shear force, and thrusts due to various types of loading. Those loadings we will study one by one. We will study all the loads individually. Then we will take one example of a box culvert on which all the loads are acting together. Okay. First one, concentrated load. In case where top slab forms the deck of the bridge, concentrated loads due to the wheel loads of the IRC class AA or A type loading have to be considered. Concentrated load on the horizontal top slab of the box culvert is nothing but the load due to the axle of the vehicle. So that is shown something like this. See here. W in this figure, if you can see this W, that is the concentrated load which is considered on the top slab of the box culvert. So for the equation for calculation of that W, how to calculate that action of load on the top slab? W is equal to Pi by E, where W is the concentrated load on the slab, P is the wheel load, I is impact factor, E is effective width of dispersion. Correct? So the total axle load of the wheel is converted to the point load, that is the concentrated load on the horizontal slab of the box culvert. How we will convert it? P into I by E, where P is the wheel load. Okay, I is the impact factor. Wheel load may be 700 kilonewton, 110 kilonewton, right, or 56 kilonewton, whatever it is, whatever axle, whatever type of class of load you are considering. Based on that, the P varies into impact factor. Impact factor varies from span and the type of construction. It may be RCC or it may be steel. Impact factor varies from that. And effective width of dispersion, we have the equation from IRC 21, which you have solved in slab bridge designs, right? Next, the soil reaction on the bottom slab is assumed to be uniform Okay, the notation used for the box culvert. Okay. So for all the cases of loads, what all you are considering on the box culvert, the soil reaction exists because your box culvert is resting on the ground. For every load which you act from the top to the box culvert, the reaction from the bottom exists. That is due to soil. Second one, uniformly distributed load. The weight of embankment, bearing coat, deck slab, and the track load are considered to be uniformly distributed loads on the top slab with the uniform soil reaction on the bottom slab. On the top slab of the box culvert, the horizontal top slab, UDL, uniformly distributed load, is considered due to various loads. What are those? One is the weight of embankment. Embankment means you will be filling the road across the roads. Okay, those filling load, that is called as embankment, and wearing coat on the road, right? And deck slab, the self weight of the slab is also considered as UDL, and the track loads are considered as UDL on the top horizontal slab of the box culvert. Next, you have weight of side walls. Okay, after the horizontal top slab, you have two side walls on both the sides of the box culvert. The self weight of two side walls acting as concentrated loads are assumed to produce uniform soil reaction on the bottom slab. Or take a box, okay, on both the vertical walls, show those vertical walls as concentrated loads which are acting on the bottom slab, that is, which are acting on the soil. Okay. Next, fourth one, we have water pressure inside culvert. So we have a vent provided in the culvert, say 3 meter by 4 meter or 4 meter by 4 meter. In the vent, through the vent, okay, the water flows, right? So that water pressure has to be considered on the side walls of the box culvert. When the culvert is full with water, the pressure distribution on side walls is assumed to be triangular. Always, in case of retaining wall design, you must have done that. Always the water pressure has to be considered as linearly varying from top to bottom. That is the triangular load. It is in triangular shape with a maximum pressure intensity. P is equal to WH at the base. Okay, at top it will be 0, at bottom it will be equal to W into H. That is linearly varying load. Water pressure has to be considered as linearly varying load always. So at bottom, water pressure is W into H, where W is density of the water and H is depth of flow. H is depth of flow. Next, earth pressure on vertical side walls. On vertical side. Now, in the vent, I have considered the water pressure. Outside the vent, you will be having two vertical walls. Okay, beside those vertical walls, you will be having the soil filled there. Okay, that earth pressure on the vertical side walls we have to consider. The earth pressure is also linearly varying in nature. See, this is the earth pressure which we have shown. It is a box culvert, right? On side walls, I am considering the earth pressure, which is also linearly varying in nature. That is W per meter square, 0 at the top and maximum at the bottom. Next, last and the sixth one, uniform lateral load on side walls. That is also called as surcharge load. Uniform lateral pressure on vertical side walls has to be considered due to the effect of live load surcharge. Okay, so apart from the live load, that is the axial load which is acting on the top slab of the box culvert. Okay, at the other ends of the box culvert, what happens due to the vehicle coming in or vehicle coming out? What happens? Some additional surcharge load will be acting on the side walls because at the entrance of your at the entrance of the box culvert and at the exit of the box culvert where the vehicle moves, that vehicle will be putting pressure on the soil which is beside the box culvert. Those additional load has to be considered on the side wall of the box culvert, so that is called as surcharge load. Totally 6 loads we have for the design of box culvert. we will revise it. First one, concentrated load due to the axle. Second one, uniformly distributed load due to the self-weight of wearing coat, embankment, deck slab and all. Next, weight of side wall, which is a concentrated load, weight of side walls. Next, we have water pressure inside culvert. In the vent, okay, when the water flows, the water pressure will be there on the side walls of the culvert. Next, fifth one, earth pressure on vertical side walls. Next, we have the last one, surcharge load, that is uniform lateral load on side walls. Okay. So now we have to design our box culvert such that it withstands the worst case. It withstands the worst case. Out of these loads, six individual loads, we have to we have to make a combination out of those loads such that we have to find out that combination which is the worst case for the box culvert, and we have to design it for that. So those combinations I will explain it now. So this is the theory part again, which I have explained. Next, see here in the design method, okay, the design of single box culvert is done by treating the culvert as a rigid frame. The moment distribution method we will be using for the design of box culvert. So once we go for the design part, I will explain you how to perform moment distribution method for the box culvert. Now, the culvert is analyzed for critical loading condition as I explained you previously. It is analyzed for critical loading conditions. The following three conditions of loadings are assumed for to be critical. So out of these three, we have three load combinations. Out of these three, any one will be the worst case or will be having the maximum moment or the maximum effect on the box culvert. So we have to design box culvert for that combination. So first combination is live load, that is vehicle load, plus dead load and earth pressure being present and no water pressure from inside. No water pressure from inside. So in this case, what happens? Live load will be there, dead load will be there. There will be earth pressure from externally on the side walls of the box culvert. So if both water pressure from inside and earth pressure from outside, both pressures exist on the side walls of the box culvert, what happens? Few of the forces or some of the forces is nullified because water will be hitting from inside and soil will be hitting from outside. So few forces will be nullified. So the effect reduces there. So if I take the empty case, if your culvert is empty, in that case, what happens? Only soil pressure will be acting on the side walls. That becomes the worst case there. Correct? So if it is some water is flowing, some forces will be nullified because of water pressure from inside and soil pressure from outside. So that is the first case, live load plus dead load and earth pressure acting on the side walls and no water pressure from inside. No water pressure from inside. Next we have the second case, that is live load plus dead load and earth pressure acting from outside and water pressure from inside here. Okay, in second case, live load will consider, dead load will consider, earth pressure I am considering. Along with earth pressure, I will also consider the water pressure from the inside. Next, third one, live load, dead load acting on the top slab, water pressure from inside, no lateral pressure due to live load. That is, no surcharge here. No surcharge, no lateral pressure due to live load. Clear? So out of these three, so if you just glance in it and if you understand the concept, okay, so first load case will be the worst case because there is no water pressure from inside, only soil pressure will be acting from outside. So as I explained, once the water starts flowing, what happens? Water pressure from inside and soil pressure from outside, it nullifies some force there. Okay, so if there is no water from inside, only soil pressure will be there and vehicle load will be there from top. So it will bulge towards inside, right? So that will be the worst case there. But in your exams, they may ask you to design for any one of these load combination. If a design on box culvert, design problem on box culvert is given, they will mention you for which load combinations you have to design your box culvert. So if they have not mentioned it, you have to take load case 1. That is the worst case. Live load, dead load, earth pressure and no water pressure from inside. Okay. Okay. So in the next class, we will go for the design of, we will go for the design of So in the next class, we will go for the design of box culvert. We will take up one example and we will solve it. Okay. Thank you.